Hello everybody, this is Miss Piekarski. In this video I'm going to go over two of our conics shapes, the circle and the ellipse, and we're going to look at the standard form of the equation and then how to graph it by hand. With both of these we're going to find where the center of your shape is and then what the horizontal radius and the vertical radius is. Okay, so let's look at our first problem. And everybody should have the packet, a copy of the packet that will have a whole bunch of instructions on how to draw these shapes by hand. I'm not going to read those instructions for you. You can read them on your own. I'm just going to walk you through the process. Okay, so our first problem, we have x squared plus y squared equals 9. And the shape of this conic is a circle. Okay, and then the center of the circle is going to be located around the origin, so it's going to be 0, 0. And I will explain how we know that when we look at the second problem. Okay, for right now, let's just concentrate on how far to the left and to the right and up and down the radius is going to be. So for that, to figure out the radius of your circle, you're going to take this number and square root it. So our number is 9, so the square root of 9 is going to be 3. So in the x direction, we're going to start at the center and move 3 to the right, and then we're going to move 3 to the left. And then in the y direction, again, we'll start at the center of our circle and move 3 up and 3 down. Okay, so let's look at the graph. First of all, on all of these problems, you do not have an x and y axis. It's just kind of a plain graph. So for each one, I will kind of explain where I want you to draw the x and y axes. And in this one, because the circle is centered on the graph, you're just going to draw your x-axis and your y-axis right down the middle of your graph. Okay. And then the circle is going to look like this. So earlier we said that it was centered at the origin and that our radius was 3. So you start here, you go to the right 3, to the left 3, up 3, and down 3, and then you just try to connect all your dots. And notice my hand-drawn circle is not perfectly round. When I look at your notes, I'm not expecting you to have perfect circles. If you use a compass, then that's doable to get a perfect circle, but you really don't need to go through all that to draw your circle. Just get it as round as you possibly can. Okay, so this is the first problem. Now let's look at the second problem. So in the second problem, our equation is x minus 5 squared plus y plus 2 squared. So this 5 and this 2 is going to help determine where the center is. Okay, so in your standard form for the circle, you should have minus signs here. So both of them should have minus signs. Because this is a plus, then that tells me that this 2 is actually a negative 2. And then notice, let's look back at our first equation. For the first circle, you notice we're not adding or subtracting anything to our x and y. So we could say that we're adding 0 or subtracting 0. So that's how we get the center of this circle was at 0, 0. All right, now on to problem number 2. So this, first of all, sorry, this is a circle, and the center is at positive 5 is your x value, negative 2 is your y value. Okay, and then same thing with the last one. This number here, whatever number your equation is equal to, that is going to be, the square root of that is going to be your radius. Okay, so the square root of 25 is 5. So we're going to move 5 to the left and right and 5 up and down. Okay. Now on this picture or on this graph, because our circle is not centered on our graph, you want to go ahead and make this line here your y-axis, and about 1, 2, 3, 4, 5 lines down, that can be your x-axis. Okay, and so we said that the center was at, let me move it back up, 5, 2, so we're going to go to the right 5 and we're going down 2. So if this is our x-axis, we're going down 2 from there. And then the radius is 5, so from this point we're going up 5 points, we're going down 5 units, we're going to the left 5 units, and to the right 5 units. And I will tell you, the bigger the circle is, the harder it is to sketch it so that it looks perfectly round. You can see here when I was first drawing this, I came in too much. It's really hard to make these perfectly round. Just get as good as you can. I do not want to see boxes. I don't want to see diamonds. Just try to get them circular, okay, because these are circles that we're drawing. All right, let's look at problem number 3. So this one, again, is going to be a circle. And I know some of you are like, how do you know it's a circle? Once I move on to the next problem, where the next problem is going to be an ellipse, and I will compare the graph for the standard form of the ellipse with the standard form of the equation for the circle, and you'll be able to see how I know that this equation here is going to be a circle. All right, so for now, just trust me, it's a circle. Now, for the center of our circle, we are subtracting 3, so my x component is going to be 3 units to the right. And notice I'm not adding or subtracting anything to my y value, so that means the y value is going to be 0. So the center of my circle is going to be at 3, 0. Now, the square root of 4 is 2, so I'm going to move 2 to the left and 2 to the right, 2 up and 2 down. Okay, on this graph, it's not a huge deal on where you put the x and y axis. However, I decided to put them here and here, just so that I would make sure I had enough space for my circle. But because we have a fairly small circle, it's not a huge deal. All right, so again, our center was at 3, 0. So my center is right here. I'm going up 2, I'm going to the right 2, I'm going to the left 2, and I'm going down 2. And notice these are always wherever the radius is always starting at the center of your shape. All right, so I think that is the last circle that we graph. Let's move on to an ellipse. Now again, let's look at this equation for the circle, and let's look at the equation for the ellipse. So on your paper, you have 4 times y squared plus 16 times x squared equals 64. Okay, because you are multiplying your x squared and your y squared by some number here, and it doesn't matter what the number is as long as it's not 0 or 1, but because we have coefficients there, this is going to be an ellipse. So if you look back at all of our circle ones, you're not multiplying by anything other than 1 for all of these circle problems that we've done so far. See, we have 1, 1. We're multiplying by 1s here and here, or we're actually just not multiplying by anything, I guess you could say. All right, so this fourth one, this one is going to be an ellipse, and I think that's where I cover, it says ellipse, but we have to do something to this equation before we can start trying to figure out where the center is and what the radius is. Okay, so that's why I have this little box here. So basically, if you read over the instructions on the very first page, one of the instructions, the very first instruction was to always set the equation equal to 0. Okay, and so, or not 0, but 1. So right here, instead of a 64, I want to have a 1 here. And there's 2 ways you can get a 1 there. You can subtract 63 from both sides, and honestly, that's not going to help you at all. So don't just subtract by 63. What we're going to do is we're going to divide by 64. So 64 divided by 64 is going to give us a 1 here. But if we divide by 64 over here, we also have to divide by 64 on the left side of the equation. So both of these terms are going to be divided by 64. And then when we divide our 4y squared by 64, we get y squared over 16. When we divide 16x squared by 64, we get x squared divided by 4. And then 64 divided by 64 gives us a 1. All right, so remember how at the very first one I said that we have a 0, 0 here because we're not adding anything to our x's and y's? It is the same case here. We are not adding anything to x or to y, and so the center of our ellipse is going to be at 0, 0. All right, now let's figure out the radius horizontally and the radius vertically. So the y direction, that's our vertical radius, and the x direction is our horizontal radius. And for all of our circles, our radii were the same for both x and y. But you'll find out for the ellipse, what makes the ellipse different from the circle is that your horizontal radius is going to be different than your vertical radius. All right, so here's how to find your vertical radius and horizontal radius. Notice that with your x squared, you're dividing by 4, and the square root of 4 is 2. So your horizontal radius is going to be 2 here. Now for your y squared, you're dividing by 16, and the square root of 16 is 4. So for both the circle and the ellipse, you have to do the square root of your number to find the actual radius. All right, let's move on to our graph. Excuse me, because this shape has the center at 0, 0, you can just draw your x and y axis right in the middle. And let's look at this graph. So our center's here. Our horizontal radius was 2, so from the center we're moving to the right 2 and to the left 2, and then our vertical radius was 4, so from the center we're moving up 4 and down 4. Okay, and so this is what the shape of an ellipse looks like. Some of you probably in like kindergarten or first grade probably learned that this term was called an oval. That's the terminology you used in elementary school. In pre-cal, we're going to call it an ellipse. All right, let's look at our next ellipse. Again, notice you're multiplying by something other than 1 here and here. And so this is going to be an ellipse. Let me just move that, although you can't see it. And we want to get this 36 to become a 1. So instead of subtracting by 35, we're going to divide by 36, and I know you can hardly see it there, but I'll show you the whole thing in a minute. But if we divide this by 36, we're going to have to divide both of these terms by 36 as well. And so when we divide our x minus 1 squared, 4 times x minus 1 squared by 36, we are going to get x minus 1 squared divided by 9, and then when I divide this fraction or term by 36, we get y plus 3 squared divided by 4, because the 9 and 36 becomes 1/4. And then 36 divided by 36 is 1. So again, my shape is an ellipse, and this time I have a minus 1 here and a plus 3. So my center is going to be at positive 1 and at negative 3. I know traditionally with our transformations, your y value, if it was plus, it was going up. If it was negative, it was going down. But this is not the case with with any of your conic shapes. So anytime you have a plus, you're going to the negative direction. All right, so that's the center of my ellipse is going to be at 1, negative 3. And then my horizontal radius, square root of 9 is 3, and my vertical radius, the square root of 4 is 2. So let's look at our shape, or our graph. Y-axis here, x-axis here. You should have plenty of space to draw your ellipse. We're going to the right one and down 3 for our center, and then horizontal radius is 3, vertical radius is 2. Okay, and just so you know, you can have an ellipse that is kind of standing up like this, or that's laying down like this, either one. Just what determines whether it's standing up or laying down is your horizontal and vertical radius. All right, last example that we're going to go through, we have this equation, and we need to divide everything by 144. And again, it is an ellipse. Because we're not adding or subtracting anything to the x, my graph is going, the center is going to be at 0 for the x value, and then -2 for the y value, because I'm adding 2 here. And then when I divide all of my terms by 144, I get x squared divided by 4 and y plus 2 squared divided by 36. And then that's going to equal 1. Okay, square root of 4 is 2, so my horizontal radius is 2, and my vertical radius, the square root of 36, is 6. Okay, so let's look at the graph. Please be very careful with this graph. It really is important that you have the x-axis and the y-axis in the correct spot, or else you're not going to have enough space for your ellipse, because it does have a vertical radius of 6. All right, so set it up like this. When you plot the center of your graph here, or excuse me, center of your ellipse here, you're going to go up 6 units, radius of 6, up and down, and then side to side your radius is 2. Okay, so that is how to graph 2 of our conic shapes. I have not talked about our hyperbolas yet or our parabolas yet, and those I will go over with you in class on Monday. Have a good day.